Alright, for number 9, you have to pick the answers that are true. So first thing we're going to do is divide both sides by 3 to isolate the e to the x plus 2. So divide both sides by 3, so that leaves you with e to the x plus 2. 75 divided by 3 is 25. Okay, now in class I solved the problems using both methods, but for now I'm just going to use the second method, where if the equation is an exponential, I change it to log. So being that the base is e, this becomes natural log of 25 equals the exponent. So now I subtract 2, and remember, it's not 25 minus 2, okay? So to avoid that, I just put the negative in the front, so minus 2 plus natural log of 25 equals x. So with that, of the 3 choices right now, this one is the one we have here. And then when you plug that into a calculator, you do get C. So both of those are the correct answers for number 9. Alright, so for number 12, it's in log form, so I'm going to change it over to exponential. So I see that the base is 6, the exponent is 2, and this is the answer I would get from that. So I would write it 6 squared equals 5/3 x. Well, I know 6 squared is 36. And so to get rid of the 5/3, to isolate the x, I'm going to multiply both sides by the reciprocal of 5/3, that's 3 over 5. So this is gone. And then, see, this is 6 times 3, 18. And then we have 3 times 3, 9 plus 1 is 10. So 108 over 5 equals x. So then that would be this one right here. And so you divide 108, because notice the other 2 choices are decimals. So you just divide 108 by 5, and you get exactly 21.6. Okay? So that would be, again, B and C. So for 24, we see whether we can write 243 with a base 3, and we could. So 3 to the x equals 3 to the 5th. So with that, we see that x is 5. Alright, so 1/8 to the x is 8 squared, but remember, the bases have to be the same before we can equate the exponents. So we just write 1/8 to the x equals 1/8 to the negative 2. So that means x equals negative 2. So for number 30, I see that I've got 64 over 27 on the right side and 3/4 on the left as my base. So I'm going to go ahead and just write 64 in base 4. So that would be 4 cubed, and 27 base 3, so that would be 3 cubed. And so I could change it to 3/4. Oops, what am I doing? Sorry. Let me erase that real quick. X like that. And so this is 4/3. Since they're both cubed, I'm going to write like this. And so bases have to be the same so that you could equate the exponents. So I'm going to take reciprocal of the right side, negative 3. So x is negative 3. So the first thing I'm going to do is divide by 6. So that leaves you with 10 to the x equals 36. And I can't do the same thing I did on 24 where I got the same bases on both sides, right? Or on 30 or 27. I can't do that. So I'm just gonna go from exponential to log. So because base is 10, it's a common log. So log base 10, I'm just gonna write log base 10, just log of 36 equals the exponent. So this would be the exact answer. Now it doesn't say to get round off to the answer to any decimal place, so I'm gonna just leave it like that. Alright, so for 36, 256 is actually 4 to the 4th. Okay, you can just put it on a calculator, and you see 4 to the 4th is 256. So now bases are equal, so I could say that x minus 1 equals 4. I'm going to add 1 to both sides, so x is 5. Alright, so they're asking you to solve the logarithmic equations. So it's in log form. I'm going to change it to exponential. So because it's natural log, I know my base is e, and the exponent is -9, and it equals x. Okay, so that would be the exact value right here. Again, they didn't ask you to round the answer, so I'm just going to leave it like that. I mean, if anything, if you want to keep the positive exponent, you could change it to this. But, okay, so that would be enough. So for 42, it's in log form, so I'm going to change it to exponential form. So my base is x, my exponent is 2, and that equals 81. Okay, so x squared is 81, so that means I take the square root of 81, or of both sides. So x is 9. Okay, so by definition the base is positive, so I keep the positive root. So 45 is in log form, so I'm going to switch it over to exponential form. Being natural log, I know that the base is e, the exponent is 5, and it all equals 2x minus 1. Okay, so I'm going to add 1 to both sides, so I have e to the 5th plus 1 equals 2x. I'm going to divide by 2, so then x equals e to the 5th plus 1 over 2, and this would be the exact value. Let me give you the decimal. I know it doesn't ask for it explicitly, but we'll just figure it out. I'll just put it in the calculator and write it down. So when you put it in the calculator, you get this number. If you round it to 4 decimal places, I mean, unless it tells you specifically like to what decimal place to round it off, then that's what you do. But sometimes I'll take 3 or 4 or 2 decimal places. Okay, unless they, on a test or quiz, I'd be specific. So for 48, for the next few problems, they ask you to simplify the expression. There's nothing to solve. It's not an equation, just simplify. So with that, notice this is an exponent and this is a log. So when you have an exponent, you could move it over here and make it a coefficient of the log, and that's what I'm going to do. Okay, so 2x minus 1 is now the coefficient of the log, and natural log of e is 1, so that cancels out. So this expression is 2x minus 1. Okay, so similar to the previous problem, I am going to excuse me, take this exponent right here and make it the coefficient of the log. And so I have -1 plus 2x times natural log of e. This equals 1, so you're left with -1 plus 2x, or 2x minus 1, same thing. So for 54, we have natural log of e to the x squared plus 2. So the x squared plus 2, that whole thing here, that's the exponent. This is the exponent right here. So this is going to come to the front of the log as its coefficient, and so you're going to have 3 minus x squared plus 2 times natural log of e. Well, natural log of e is 1, and so I'm going to distribute the negative. 3 minus x squared minus 2. Combine the 3 and the 2, or -2 with the -2. So that's going to give you negative x squared. 3 minus 2 is 1. Okay, so that would be the answer for this one. Okay, 57, I could go straight with using the logs and all that, but notice how 0.2 could be written as a fraction, 2 over 10, right, which is 1 over 5. So 0.2 is 1/5. So I'm going to say 5 to the negative t over 2 equals 1/5, okay? But seeing that the left side has a base of 5, I'm going to say 5 to the negative t over 2 equals 5 to the negative 1. So now that I have common bases or like bases, I'm going to set the exponents equal to each other. So there was no need to use logs in this problem. So I'm going to divide both sides, not divide, but multiply both sides by negative 2. Okay, negative 2. So that the t is isolated, and negative 1 times negative 2 is positive 2. So on 60, the first thing I'm going to do is divide by 100. And so you get e to the 0.005x equals 1,250. And so that's as far as I can go by hand. I've got to, either do the, take the log of both sides, method 1, or change the exponential to a log, which is what I'm going to do. I'm going to change this exponential to a log. So base is e, so natural log of 1,250 equals the exponent. So you want x by itself, so you're going to divide by the coefficient of x. Okay, so x has this exact value. Take your calculator to get the approximate value. So after you punch this into the calculator, you get 1,426 and they want you to round to 3 decimal places, so that's 1797. So it's actually 180. Okay, so this would be the answer. So first thing you're going to do is isolate the e to the x. So I'm going to subtract 7 from both sides. So that leaves you with negative 2e to the x equals negative 6. Now you're going to divide by negative 2. So that leaves you with e to the x equals 3. And so now you're going to take the log of both, do the log of both sides, or I'm just going to change it to log form. So that's natural log of 3 equals x. And so this would be the exact value on the calculator. On the calculator, it would be 1.099 if you round it off to the nearest 3 decimal places. Alright, so the first thing I'm going to do is subtract 15 from both sides, so the 6 stays there for now. And so 2,601 minus 15 gives you 2,586. So now we divide by 6 because you want to isolate the 8 with the power with the x and the exponent, and divide by 6. And you get 8 to the negative 2 minus x equals 431. So it's an exponential equation, so I'm going to change it to log form. So log base 8 of 431 equals the exponent. So this whole thing right here is the exponent, right? So this is what goes on the right side. And so now I'm going to add 2 to both sides. So remember, I add the 2 and I write it in the front of the log. That way you won't be tempted to add the 2 to the 431. Okay, so I'm putting it in the front. Equals negative x. And so now I'm going to divide by negative 1 or multiply by negative 1, however you want to see it. So this negative 2 minus log base 8 of 431 equals x. Okay, so I'm going to just move up here. So negative 2 minus, now the calculator does not have a base 8, so